Good morning, another day, another Lewe. Been doing some serious thinking about the propagation of the shock of load as it fragments. So I believe that Dr. Lewe's thesis proves that rest mass is incorrect and that it's a positive moment, and that there is a reaction in a clockwise direction from the anti-clockwise motion of the fragmentation of load in a beam, and that translates itself into the fragmentation of load inside an atom, because Lewe allows us to identify load fragmentation at infinite scale. So the smallest possible scale that we can analyze the fragmentation of load at the point of failure in a beam is the meter 4, the second momentum area, which is created inside an atom. Okay. So here's Lewe today. I want to show you this important drawing, and I want to show you that he's taken it from 0 to 6. And so what he's showing is this is anti-clockwise. Assume this is the anti-clockwise vortex that is developed. And you'll see that it goes to 6 and that there is something different happening there than is happening there. There is a displacement occurred in terms of the relationship between tension and bending within the anti-clockwise wave. When you look at how those waves are performing, you'll see there's a rotation. There it is. These two rotations. This is the anti-clockwise rotation. This is the clockwise rotation that he's showing. So this is the vortex. The resultant of the vortex looks like this. The resultant of the clockwise vortex looks like this. And it's greater. There's an imbalance between the two. And then the reason that there's an imbalance between the two, of course, is our old favourite, this drawing. Now, notice it goes from 0 to 5, not to 6, because he's not showing the final step of the positive moment, which shows the clockwise rotation of the positive moment. And so I'm going to try and show that to you what I mean. So here's Lewe's figure 14. Here are the loadings, and here are the wave patterns, all from Lewe's conclusion. And I'm going to show you that this motion, the anti-clockwise rotation, comes from there, from adding the 6th location and the 6th layer of load fragmentation. So Lewe shows this as going straight up. I'm saying it should be rotational, and I'll show you why. So the first thing that happens is we get a fragmentation of the load into 3 equal parts. The load expresses itself there, and I'm saying it's because of this anti-clockwise motion, and Lewe shows it as being there because the load has now increased here, and that this load is now expressing itself here. So what's happened is this is a hemisphere of elasticity reflecting an area of gravity, of time gradient, where everything is equal. And those 3 are showing the same load relative to gravity. The first point of call is that this motion, this load, is attracted to this load, which is spinning with an anti-clockwise force on it. And so its motion is to there, and that it joins. The membrane is now 2. So if you can say that's pi, this is 2 pi diameter. The next motion is that because this is spinning, it now enlarges, and it's now 3 pi hemisphere into the center. The next motion is it stays the same size, but it moves, its center of rotation moves. So its axis of its spiral spin has now taken this hemisphere to here, at which point it becomes subject to the clockwise load that Lewe shows us, and that adds an imbalance to the hemisphere. It's now heavier on this side. This elastic membrane is heavier on this side because of this rotation. And then finally, in its final phase, it balances and it reaches the other side. So it's now defined, the width of the load fragmentation is between 0 to 6, and it's moved from where it was in position here to over there. The shock wave of the load fragmentation has arrived over here. Now in this is what I've shown here as this bar pulling apart. Now these are all the loads grouped here, and assuming that I'm pulling a bar apart in this direction, 90 degrees to here, but it's been caused by bending. I'm bending this bar of enormous length that the final break is actually at 90 degrees where the fracture occurs inside the meter 4. So you can see the pattern repeats, that you've got this pattern, you've got the same pattern here in negative space, and the same down here, but you've got a difference. Those 3 dots there, when the load is in this position, is now replicating what is happening here. So the cycle has repeated, that we've got our 3 equal forces apart from that balance is now carried through to that point to make the hemisphere. And so this is the anti-clockwise force. I'm saying that the spaces are the clockwise forces that are being created. And if I find I was trying to show the propagation of these hemispheres as a wave. And so here again is our shapes, and I've coloured them to try to make us see the phases of the load fragmentation. And you can see it goes from A to B to C. C then moves to D. D then expands to E to F. And F is the final one. It's run through to F. And so when it gets back to G, its final move would be that the centre of this final wave, which encompasses the positive and the negative moments, encompasses the whole space from 0 to 6, and that's that big circle which is centered here again at A. Because we've replicated now what's about to occur here, where in the next moment it will repeat or not repeat. And this is the only difference in terms of load. When a beam is in stability, the forces are balanced, and that the time gradient that this represents is preserved. But when you look at a beam, you see that it has a time gradient from there to there. I'm bending this bar. The time gradient is equal there and there. At the moment that it separates, the time gradient is now unique to each of the individual spaces. And then the time gradient is how the gravity affects it. And so it will move towards its natural time gradient, which is the motion that we see here. So can you see how what we're saying is that when you use matrix calculus to reveal this fragmentation pattern and this wave dissipation, shock wave dissipation pattern, this is the anti-clockwise, that this space is the clockwise motion. We know from Lewe's calculations that the clockwise rotation is stronger, and therefore the clockwise rotation, which is stronger, is driving the anti-clockwise rotation, which begins up here in the next moment. And in terms of a beam, that defines whether it's going to stay up or collapse. In terms of an atom, it determines whether it's going to stay in one piece or fly apart. Okay, so that's really Lewe. That's Lewe. So this paper in 1915 proves that rest mass is only a window, an assumption that is made to allow you to analyze all the action that you see and observe in science using matrix calculus. But once you know that you're using matrix calculus, you then can use that to demonstrate that the rest mass is actually a clockwise rotation, and it moves tick and tock, and that the resultant is a clockwise 137 arcsecond rotation of the whole system. And that's all you need to do with physics, is to fix your foundation, is to remove rest mass, replace it with clockwise moment, the positive moment, the anti-clockwise rotation, creating the clockwise motion. So that's why it's really important. The foundation of physics, to fix it, was only ever going to be something really so simple, because everything that you know has to still work when you make this switch. It's this switch that science knew in 1915. And when it looked at the paper from Johannes Stein in 1914 that told you that if you want to use matrix calculus on relativity, you must assume rest mass and you must normalize infinities, thus opening the gateway to matrix calculus. If you want to understand what you're looking at, you need to close the gateway of matrix calculus and refer back to classic mechanics and structural engineering, and you can see what's happening. So, foundation of physics repaired today if you accept this paper, and then we can all get on with the future. So I hope I've been helpful. Any questions, please ask. Remember, love rules, do the work, choose.